So what happens?
Oh, yes, I think.
Yoav, did you see graphically where it's going to?
Yeah, 0.
0? So at the beginning of the year, I asked you guys to memorize one of these, which was sine x over x as x goes to 0, that equals 1. There was another one in that chapter, which was this. And I need it right here today to do a proof for you. You don't need to know it otherwise, but I can't get it. Right at 0, it's undefined. There we go. At 0, it's undefined. However, it has a limit. It goes to 0. Okay, cool. And before you panic, you do not need to remember these trig expansion things, but I need to show it to you for a proof that I'm going to show you today. And it's motivation for, like, I'm going to show you how to derive all of these derivative patterns from limit definition of derivative. And you don't have to memorize them, but then that means you need to be able to prove them. So it's kind of a good idea to try memorizing. Does anybody remember this, though, from pre-cal? Sine A plus B?
Barely.
Hanukkah? No? Okay, so I see sine as the hippie function, intertrigonometric relationships, and different angles, mix and match, sine, the sines match. It's a very friendly function. Sine A, cosine B, intertrigonometric marriages there, and then the alternating, the different angles, sine the sines match, then it's cosine A, sine B. And again, you don't need to remember this, I just need it for proof that I'm going to do in a second. Okay. Limit definition of derivative. And you don't need the graphing anymore, so you guys can put the laptops away. Sorry to all that for just a little bit. How am I going to do the limit definition? What is that? Felipe, do you remember?
F of x plus h minus f of x over h.
Okay. Yep. So it wasn't f of x in this case, it's sine. And the hippie function, sine, cosine, sine the sines match, cosine, sine. All right, what can I do with this? It's
Factor the top.
factor the top. How does the
wait.
top? Because nothing comes out of all three. But they're. I mean, I can factor a little bit, but I need to do some rearranging. Are we allowed to rearrange? Yeah. Okay. So when I take sine x out of those two pieces, I get cosine of h minus 1 and did Yoav tell us in the beginning? He looked at the graph, the limit is h goes to 0 of cosine h, oh, sorry, the limit is b goes to 0 of cosine b minus 1 over b. What did that become? Looking at the graph, the limit that we just did. 0. So this was 0. And from the beginning of the year, sine of h over h, as h goes to 0, what is that? 1. All right, so this comes out to be sine times 0, and this comes out to be cosine times 1. So the derivative of sine is cosine. And we did do this, looking at it graphically, when we were doing that, hey, match the derivative with, here's the curves and match it with its derivative. Horizontal tangent here is a 0, horizontal tangent here is a 0. The slope between those, that high and that low, was negative and continuous, so it's going to make a loop. This slope was positive. So the red curve, its derivative is the black curve. Derivative of sine is cosine. All good? And because I can, I'll do limit definition cosine. And cosine's expansion, it's the cranky one. It keeps its co-conspirators close. Cosine's contrary and it has opposite signs. It's negative. And I'm going to do the same thing I did a second ago. Sam said, factor the one thing and then rearrange. If the pen will change color. And I get the same deal. That goes to 0. This goes to 1. So what's the derivative of cosine look like?
Negative sign.
Negative sign. Okay. Using those two, do quotient rule with this. What do you get?
Excuse me.
Constantine, what'd you get?
I got cosine squared x minus 2 cosine x plus sine squared x over cosine x minus 2 squared.
Okay, say again?
Cosine squared x minus 2 cosine x plus sine squared x over cosine x minus 2 squared.
Okay, you're not done. Not wrong, but it's not done.
It's sort of like an identity.
Uh-huh.
I just didn't remember that identity.
Okay, the one identity that you need to know of all things is this one.
Okay.
Wait, so cosine squared x plus sine squared x is 1?
Then cosine squared plus sine squared equals 1. And that comes from the unit circle business. Sine is opposite over hypotenuse. When the hypotenuse is 1, I get sine x. And then there's cosine, so then the Pythagorean theorem, cosine squared plus sine squared equals 1. You need to know that one.
Okay.
So he did the bottom function times the derivative of the top derivative of sine, you just learned it. Positive or negative? Positive. Minus the top times the derivative of the bottom. What is the derivative of the bottom? Negative sine. All over the bottom squared. Leave it factored. I'm writing this note on everyone's papers that continues to keep distributing. Leave it factored. Distributing here, we get exactly what Constantine had, cosine squared minus 2 cosine x. Distributing here, positive sine squared. So it becomes 1 minus 2 cosine x over stuff squared. Good? Okay. All right. I want to find all of the derivatives though. Tangent is what two trig functions? Sine over cosine. Okay. So figure it out. Do quotient rule. What is the derivative of that? Kinda, it's a little old. So, some people said secant squared. Some people said negative secant squared. Other answers? Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. This becomes cosine squared plus sine squared. Okay, so the derivative of tangent is secant squared, positive secant squared. All right. Cool. Cotangent is, so figure that one out. What's the derivative of cotangent?
Oh, it's
You
cosine.
got quotient backwards?
No, I was thinking about tangent.
No, that was for the last. But I think the cosines are supposed to go first. Because it's not much of a derivative.
You get quotient backwards.
I'm at it.
Derivative of cosine is positive sign or negative sign?
Negative.
And derivative of sine is
Positive.
positive.
Cosine.
Cool. Derivative of tangent was secant squared. Derivative of cotangent is negative cosecant squared. Yeah.
So that means, if you have, could you take the inverse of one to get the other, because, cotangent is the inverse of tangent and negative cosecant is the inverse of secant.
So you're saying to do the inverse
Right, no,
of,
never mind. Forgot the negative.
yeah, they're not exactly the same.
One's inverse, one is perpendicular.
Okay, secant, how do I do the derivative of secant?
1 over cosine x.
1 over cosine. And do quotient rule with that. Okay. What's the derivative of 1 over cosine? Secant x, tangent x? All right. So the last one. Derivative of cosecant. Okay, what's the derivative of cosecant?
Negative cotangent cosecant.
Negative cotangent cosecant. Okay. So let's put them together. Sine, derivative of sine,
Cosine.
positive cosine, positive, okay. Derivative of cosine, negative sine. Derivative of tangent, secant squared. Derivative of cosecant, derivative of cotangent is negative cosecant squared. I know, because it does make sense that it should come after the tangent, and I didn't write it there. Okay, derivative of cosecant.
Negative cosecant.
Okay. From the twisted mind of Mr. Orlando, here's a mnemonic to help remember some things. Some of you know this already, like, what's one pattern or thing that you notice?
Cosecant's always negative.
Okay,
That's what I was.
I would go further than that. All the ones with C are contrary, contrite, counter. Pick some word that begins with the letter C that means the opposite. All the ones that are with C are negative. Okay, and this is the Mr. Orlando rule. Trig, they're all like in a clique. Sine and cosine are the cool kids. Everybody wants to be with them. They are each other's derivatives because, you know, they're cool. The other ones want to have friends too, but they're losers. These guys are friends. They're lead dogs. Tangent wants a friend. Which friend? It's going to take the one in its Pythagorean identity. Derivative of tangent is secant squared. Derivative of cotangent begins with C, so it's negative cosecant squared. Secant, cosecant, they're just the losers of the bunch. They're so lame, they need to, like, secant sucks, puts itself in its own derivative and brings a friend. Rude. So, derivative of secant is secant tangent. Derivative of cosecant, contrary, begins with one of those C's, so it's counter, it's negative. Cosecant, cotangent, it brings a friend, puts itself in its own derivative and brings a friend. Memorize them however you wish. But this is a thing that will be true when we do trig inverse, like sine and cosine, oddly, hang out together a lot. Tangent and secant also hang out together a lot. And same with cotangent and cosecant, they're buddies. And remembering or knowing how to derive these is super helpful. Okay? Okay, this one you need a calculator, just to get numbers. Do you remember how to find the tangent line? How many decimals? 3, at least. And calculus. Degrees, radians, or doesn't it matter? Radians. Absolutely make sure your calculator's in radians. And you guys know how to change Desmos to say radians? No? Okay.
It's like the wrench thing.
It's the thing. So click the wrench, highlight radians versus degrees. It gets so confused when you're trying to do trig in degrees, it's like disappears.
Really?
Sorry, I should probably put the problem up again. My bad. Sorry. My bad. What are you doing? That's not the way to do it, but, so, well, that's not what I'm asking you to do, but, let's see, second, calculate the derivative at,
How do you like set?
at one.
Oh, that's it.
But that's not what I was kinda wanting you to use the calculator for.
Oh, okay.
It's fine, I'll calculate it too.
A number of people in first period were like, how is that your derivative? What are you talking about? Where did that come from? Product means product rule. First times the derivative of the second plus second times the derivative of the first. Plugging in 1 for x. I get negative sine 1 plus cosine 1. So how do I put the pieces together to get a tangent line? Sophia?
What?
How do I put these pieces together to get the tangent line?
You would have to, wait, sorry.
This is 0.540 and this was negative 0.301. What was it?
Negative 0.301.
Negative 301.
Would you do like y minus and your y value?
Yep. Y minus the y value, keep 3 decimals even though it's a 0.
And then your slope, and then x minus your x value, which is 0. Yeah.
3 decimals, if you left it as 0.54 and didn't keep the 0, AP gets cranky at you.
It's take out points if you don't include the zero?
Uh-huh.
Wait, seriously?
Seriously, like, you do all the work, you plug in and you get the value for cosine of 1, which, if you left it as cosine 1, like it's on the calculator piece of the test and your calculator breaks, which they do have Desmos active for you, so that would mean your computer shut down and then you're really screwed. But you could leave it as cosine 1, because that's a thing that can be evaluated in a button push.
And then, so like if you had to, if it was like 0.545, would you round that, or no, just leave it as 0.545?
Okay, rounding, you can truncate or round. So I could leave this as 0.540, I can keep an extra one, 3. This one, 0.301. In both of these cases, the rounding and the truncating are the same. Truncate just means keep 3 decimals and cut it off. I don't care if it was supposed to round up or down. I can just cut it off. Because half the time it's not the same answer. Okay, this is what it looks like. Some of you typed it in and did that. If you type that in, that takes you to the calculator and it will tell you the derivative at that spot. If you don't know how to use it, I'm not actually going to teach you, though I did just tell you. All right. Other things I need to remind you or tell you about. Chapter 3 is huge. There's 9 sections and there's just derivatives galore going on in there. So last year was the first year I did this. It used to be a 2-day test, 1 calculator portion and 1 non-calculator portion. Instead of having 2 horrendous days together where you guys stress out for 48 hours and then I grade for like 100 and something, I'm splitting the test up. So there's going to be a test on 3.1 to 3.6. I will get your quizzes back to you hopefully tomorrow. Speaking of inches of paper, I've done some of them. So I'll get the quizzes back to you tomorrow, but we just did derivatives of trig functions. Tomorrow is chain rule. Friday is review of whatever questions you have, and Monday is going to be a test on this first half of the chapter. Cool? This is tonight's homework. It is all the circled guys. And if you prefer to look at a textbook, there's some behind this table. Yeah, it's with a calculator. I think it is without calculator. Do you want to get started?
What page is this?
Good question. I don't know. It is page 140. 1 to 21 and 27 to 28.
This test are really hard. Bro, what? Just one.
And the rest of it was just, there was like a couple questions.
Well, but
Wait. It's 140. And which numbers?
All the ones that start over. Numbers 1 to 9, no, 1 to 9.
To 9.
1 to 21 on, 11. I got that. 13.
What is that?
guys, again, if you want
No, that's 3.
to take pictures of the textbooks, there's a couple of it.
Yeah, I'm confused.
1 to 21 on.
Why do the numbers read?
That like felt way too